Hello, my dear Java learners. Welcome back to our channel. Today, we are diving deep into a super important topic for every professional Java developer, Hibernate Object Relational Mapping Fundamentals. This is an advanced topic, but I promise to make it easy to understand. By the end of this tutorial, you will have a solid grasp of what Hibernate is, why we use it, and how to perform basic database operations with it. We will cover the core concepts, look at practical examples, and discuss some common mistakes to avoid. So, grab your virtual whiteboards, and let us begin this exciting journey into the world of Hibernate. Get ready to unlock the power of seamless database interaction in your Java applications. We will make complex concepts simple and practical for you. Let us start with the very basics. Alright, so what exactly is Object Relational Mapping, or ORM, and how does Hibernate fit into this picture? Imagine you are building a Java application, and you need to store data persistently in a relational database like MySQL or PostgreSQL. Traditionally, you would write a lot of structured query language, or SQL, code to interact with the database. This creates a mismatch between your Java objects and the database tables. This is where ORM comes in. ORM provides a bridge, allowing you to work with database data using familiar Java objects rather than raw SQL. Hibernate is the most popular, powerful, and robust ORM framework for Java. It handles the mapping of your Java objects to database tables and vice versa, significantly reducing the amount of boilerplate code you need to write. It makes database operations much more intuitive and object-oriented. On the whiteboard, you can see how Java objects seamlessly map to database tables, all thanks to Hibernate. Now that we understand the why behind ORM, let us look at the core components of Hibernate. The first crucial concept is the entity. An entity is simply a plain old Java object that represents a table in your database. For example, if you have a student table, you would create a student Java class, and using special Hibernate annotations like @entity and @id, you mark it as an entity. The @id annotation specifies the primary key of the table. Hibernate uses these annotations to understand how to map your Java class to a database table and its properties to table columns. It is like telling Hibernate, hey, this Java object corresponds to this database table. This makes your code clean, type-safe, and much easier to manage compared to writing manual SQL statements for every operation. Okay, enough theory. Let us see Hibernate in action by performing a basic create, read, update, delete, or CRUD operation, saving an entity. Here, we have our student entity class. To save a student object to the database, we first need to get a session from our session factory. Then, we start our transaction. A transaction in Hibernate ensures that a set of database operations are treated as a single atomic unit of work. Either all operations succeed and are committed, or if any fail, all are rolled back. This maintains data integrity. We create a student object, set its properties, and then call session.save student to persist it. Finally, we commit the transaction. It is that simple. Hibernate takes care of generating the appropriate SQL insert statement behind the scenes. This is the magic of ORM, making database interactions feel like working with regular Java objects. While Hibernate simplifies database interactions, there are some common mistakes developers make. One frequent error is forgetting to manage transactions properly. Always remember to begin a transaction, commit it upon success, and roll it back if an error occurs. Another common pitfall is the n+1 select problem, where Hibernate performs n additional queries to fetch child objects, leading to performance issues. You can mitigate this by using proper fetching strategies like join fetch or batch fetching. Also, be mindful of lazy initialization issues, where accessing a lazily loaded collection outside of an active session can throw an exception. Best practices include always using explicit transactions, optimizing fetch strategies, and ensuring proper session management by closing sessions when they are no longer needed. Always check your SQL queries generated by Hibernate to ensure they are efficient. And there you have it, my friends. We have covered the fundamentals of Hibernate object relational mapping. We started by understanding what ORM is and why Hibernate is indispensable for Java developers. We explored core concepts like entities, session factory, and session objects. We then saw a practical example of how to save an entity to the database using transactions. Finally, we discussed common mistakes and best practices to help you write robust and efficient Hibernate applications. Remember, practice is key. Try creating your own entity classes and performing different CRUD operations. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming content. Keep coding, keep learning, and I will see you in the next video. Happy coding!